So guys, going to start to talk about here electric potential. So let's say we've got this block here and we raise it up above the ground. It's going to have potential energy when we do that. More specifically, it's going to have gravitational potential energy. And if we let it go, that potential energy would change into kinetic energy and we could get some work done out of it. And so we could pound this stake into the ground, for example. Well, similarly, let's say we had a negative charge and a positive charge. If we separate the two, it will have potential energy. In this case, electric potential energy. Because if we let it go, that positive charge will zip down because opposite charges attract, and it will get kinetic energy in that case. So this is what we call electric potential energy. Energy that a particle possesses due to its position in an electric field as opposed to a gravitational field. So there's something different, and this gets a little confusing, but it's just called electric potential. And that's what we're going to focus on in this little lecture. Electric potential is how much electric potential energy you have per unit of charge. It might be a bit easier to see if we put it into an equation form. So the electric potential is the electric potential energy divided by the amount of charge we have. So let's say we had 10 joules of electric potential energy, but we had 2 coulombs of charge. 10 joules divided by 2 coulombs would give us our electric potential of 5. When we try to abbreviate this equation, you'll see this top part written a lot of different ways. Here they've written it as PE for potential energy. The E stands for electric. Down on the bottom, if I can get that little bar to go away, there's a Q for charge. And the symbol for electric potential is a V, and we'll talk about why in just a second. Let's focus in on the units here. So since we have a potential energy here divided by an amount of charge, energy is measured in joules, charge is measured in coulombs. So electric potential is the joules per coulomb. We have since renamed joules per coulomb a volt. And that is why the symbol for electric potential is a V. So what is a volt then? I'm sure you've heard of a volt. Maybe you think of here we have a 9-volt battery. Well, now we can understand what that means. When we say this battery has 9 volts, we mean we are giving 9 joules of energy to every coulomb of charge that's in that battery. Notice we are not saying how much energy is in that battery. We're saying how much energy we're giving out per chunk of charge. It's kind of like we're saying, in a sense, how much energy we're giving to every electron here. You probably have a AAA battery in your TV remote. AAA batteries, and maybe you can just see it stamped on the side right here, or look at your own AAA batteries. They're 1.5 volts. So that means they have 1.5 joules of energy, far less, per every coulomb of charge. And that's how we split up the two there. So let's say we have this positive charge sitting right here. It's got a certain amount of electric potential to begin with. We'll call that its electric potential initial. If we want to move it closer, we got to do work, and that's what the hand's doing down there. We would have to push on it somehow. When we moved it up here, we would have a new, higher electric potential because we'd have more energy because the two would be repelling each other like a spring. We could call this the final electric potential there. So when we go from one to the other, we create a difference in electric potential. Sometimes we just call that the potential difference there. So potential difference is the difference in electric potential from one place to another. Because it's measured in volts, potential difference is often called voltage. And so that is what I'll probably call it from now on. But if you see the word electric potential, or if you see the word potential difference, and if you see the word voltage, there are some technical minor differences in those. We're going to not address those differences. So voltage and electric potential, we're going to treat as exactly the same thing. And potential difference and voltage are exactly the same thing. They're just two different names for that. So this is part one. We'll finish up with voltage in the subsequent little video here. If I can stop the video.